Okay, today we're going to work with point slope form, our second linear equation. Now, this equation is not really used to graph. It's not really used to do quadratics. It's the third linear equation. It's the second one we're discussing in class. But what it does is, if we're given different pieces of information, we can put it into point slope form, and then we can convert it into slope intercept form and actually graph it a little bit easier. So this is the actual equation. We're going to do y minus y1 equals mx minus x1. And once again, the m and the x and y are in different colors because we're going to input information into that equation. All right, m, just like before, is our slope. So either we're going to be given a slope or we got to calculate out the slope. So m is the slope. So we're going to plug the slope in. The x and the y, though, are going to be any given number on the graph. All right, we have a line. There's lots of points on the line. We can choose any point we want. We can plug it in, the x value in there and the y value in here. So x1 and y1 are simply any point on the graph. All right, by that I mean obviously the line, not the four-quadrant grid. You can't just pick any point on a graph. It has to be pertained to the line. The difference between point slope and slope intercept form. Slope intercept form uses a point, but it uses a point right at the y-axis. You might not be given that in class or on a homework assignment or on a test. You might be given some other random point. And all you do is plug information in. So, for example, let's just do one while we have this on the screen. Say I'm given my slope, or so let's not use y-intercept. Mistake. All right, so say our slope is 1/3. And the point on the line is, everybody uses 3, 5. All right, there's my slope of the line. There's my point. All we're going to do is take and plug this information into this equation. That's all we're going to do. All right, so if I was to write this equation out, I do y doesn't change. You always have to have an x and a y in your equation, minus my y value, which is 5. That's going to equal my slope. My slope is 1/3. And then I'm going to do x. And I'm going to subtract my x value, which is 3. So that right there is an equation in point slope form. All right, I got my x and my y values, my 3 and my 5 written down here. I have inputted in my slope. So now we can use this, and we're not really going to use this and graph this directly, but we can take this and we can convert it into slope intercept form and make it much easier to graph. So let's do that. So on the next screen, I have, let's use red. All right, so I have my slope and I have a point. I have my x and my y value. All right, so let's write it out again, just like we did on the last screen. All right, so it's going to be y equals y minus 1, m, x minus x1. All right, so we're going to plug our information in. All right, the first y is going to stay. Now I have my x value, my y value. Now, my y value is a -2. So it's still going to be, didn't mean to put minus, or equals. Now if I do y minus 2, because my y value is a -2, and I definitely have to subtract it. Whenever you subtract a negative, really what you're doing is you're adding them together. Pretty much in math, whenever you have like a double negative or you're subtracting a negative, it turns it into a positive or a plus. All right? And realistically, what you want to remember is if it's a negative up there and you plug it in, all it does really is change the sign. All right, equals, my slope is 1/4. I still have my x. Now my x1 would be the value here, because this is technically x1, y1. So I'm going to subtract 8. All right? That is point slope form. But like I said before, I can't really graph that. I don't know where to start. I have my slope, and I do have a point on there, so I guess I could kind of graph it. But I'm sure in math class they want you to convert it to slope-intercept form first. I know I do in my math class. All right, so let's change this up. Let's actually turn this into slope-intercept form. So we have parentheses. So the one thing you can always do when you have parentheses is you can take the number on the outside and distribute it or multiply it by both items on the inside. I can't do anything to the left side of the equation. I can't add 2 to y right now, so I'm just going to leave this alone. Y plus 2 equals. I can distribute that 1/4 to the x and to the -8. Remember, by distribute, we mean to multiply. So 1/4 times x is 1/4x. And then 1/4 times 8 is like saying 1/4 times 8, -8/1. And all you're doing is multiplying fractions. So 1 times -8, give me -8 on top. 4 times 1 gives me a 4 on the bottom. All right, let's clean that up a little bit. What's -8/4? That's right, it's -2. Let's change that from a fraction to +2. All right, I'm almost there. I almost have slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So it's almost in that form, except I have a +2 after the y. Up here I have an equal sign, so I need to get rid of that +2. So in algebra, whenever you want to move something or get rid of it, you do the opposite of whatever it's telling you to do. Here it says to add 2. So instead of adding 2, we're going to subtract 2 to take it away. But whatever I do to one side of the equation, I have to do to the other side. So I'm going to subtract 2 from this side as well. I'm going to be left with y equals 1/4x. But wait a minute. I subtracted that away. Actually, that should have been a negative. There you go. Should have been negative. Oops. Yeah, because -1 times -8 is -8. And then 4 times 1 is 4. Yeah, that should have been a negative. Even math teachers make mistakes sometimes. All right, so that should have been a -2 there. So I'm going to subtract 2 more, which gives me a -4. Because -2 minus 2 more is a -4. I've canceled that out. Now I have it in slope-intercept form. All right. I thought something was wrong because when I first did this before the video started, I kind of worked through it in my head. I'm like, okay, that gives me a starting point. All right, so my starting point is now that's my y-intercept. If you're not sure about slope-intercept form, please watch my slope-intercept form video, which I just made minutes ago. That's my starting point. So I'm going to go to -4 on the y-axis. And then I'm going to use my slope to get to my other point. I'm going to go up 1/4, up 1 over 1, 2, 3, 4. Put my next point there. And I have graphed that equation. All right? We made it work. So, actually, if you think about it, if I was to actually draw this straighter, because it's kind of bent up a little bit, this line should actually go through this point, which is -8, -2 here. So if I was to drawn that like a little straight, let's do a better job of that line. So you're not using a ruler, it's hard to draw a straight line all the time. See, now these are all like in a different line, because look, I go up 1/4, up 1/4, I have the other point. There you go, that's a little bit more accurate of a line. And so there's the equation, and I'm sorry, there's the slope, the point, and I was able to put it in point-slope form and then eventually put it in slope-intercept form. All right, let's do one more. Because here, you had slope and 1 point. Sometimes your math teacher will throw a curveball at you and give you 2 points and no slope. So what's the first thing we need to do here? Find the slope. So we're going to take our difference in y's, which is y2 minus y1 over x2 minus x1. That's the equation we use in algebra to find your slope. I'm sure it's all over your math classroom. I know it's all over my math classroom. So what I'm going to do here is I'm going to take both my y's. I have an x and a y. I have an x and a y, and I got to find my slope first. So I'm going to call this x1, y1, net x2, y2. It doesn't really matter what order you go in, as long as you go in the same order for your y's and for your x's. All right. Subtract my y's. This is going to be 6 minus 5. There we go. y2 minus y1. On the bottom, I change an x. 4 minus 2. A difference in my x's. So I get 6 minus 5 is 1. 4 minus 2 is 2. My slope is 1/2. All right, so I have my slope. My rise is 1, my run is 2. It's 1/2. Now, I need a point. I have 2 of them to choose from. It doesn't matter which one you choose. You can use either one. All right? Either one. Now, just a little recommendation. You're going to be calculating with a half. So I'm going to be taking probably a half of one of the numbers. If I look at here, I have a 2 and a 5. I might end up have to take half of 5, and that's going to turn into a fraction. Who wants to mess with fractions when you don't have to? So I'm actually going to use this point right here. It's going to make it a little bit easier for me in the long run. So I'm going to plug my slope and my point into my equation. So it's going to be y minus 6 equals 1/2 x minus 4. Now it's in point slope form. Once again, I can't really graph that, but I can convert this into slope intercept form. I'm going to distribute this side. I could have taken 1/2 of 2 and gotten 1, but just in case, whenever you have a number up here, it can easily go into one of those numbers. Just choose that instead. All right, so here I get y minus 6. 1/2 x is with my slope and my x value. 1/2 times -4. What's half of -4? -2. I'm almost to slope-intercept form. I need to get rid of that 6 out here. Because remember, slope-intercept form is y equals something, not y minus 6 equals something. The opposite of subtracting 6 would be to add 6. I got to add 6 to both sides. If I cancel that out, I'll get y equals, I still have 1/2 x. That's not going to change, although my board's acting crazy on me today, as it does in class sometimes. We'll write it up here. Y equals 1/2 x. 1/2 x, and then -2 plus 6 is a plus 4. So there's the equation. Everything's acting really weird today. All right, there's my equation. That's in slope-intercept form. Now let's graph it. So my starting point would be plus 4 on my y-axis. Here's my y-axis. There's my x-axis. This is going bonkers today. So plus 4 would be right here on my y-intercept when it comes to slope-intercept form. I can use the slope to find my next point. I'm going to go up 1 over 2. Up 1 over 2 is right there. Just to be safe, I might do a up 1 over 2 more, just to kind of create a more accurate line. So if you're asked to plot that point, asked to graph that information, yes, you could probably just put those 2 points on a graph and draw a straight line. But usually you're just asked to create an equation in point slope form and then convert it into slope intercept form. All right. If you have any questions, please ask me in class. If you're not in my class, or even if you are, give me a like down below. Leave a comment. Like I said before, if you guys ever need any extra help in any other form of math, maybe put a comment down below. And if I can, I will make a video for you. All right, you guys, have a great day.